All right, guys, I've got a new section called combinations. If you remember last week, we did permutations. And to go along with that, we're doing combinations, which is a little bit different. Here's what a combination is. A combination is a selection of R objects from a group of N objects. The same thing as permutations there, but here's the difference, where the order is not important. So it doesn't matter which order you choose them in. We're not counting orders or arrangements, just how many different combinations of things there are. For example, the most famous example is probably picking committees. If I were to take a committee from our class, for example, and take 3 certain people, it would not matter which order I pick those people in. If I pick person A, person B, and person C, that's the same as picking person C, person B, and person A. It's the same committee. So that's what a combination is. Still selecting objects from a group, but order doesn't matter. Order is not important. That's a big deal. Okay, and here's the math part. Here's how you find it. The way you find a combination, remember we did NPR the other day, now we're doing NCR, and there's the formula for it. Basically, you take the bigger number, the total number of objects on the top, and on the bottom you do N minus how many you're selecting, and the R also. So I'll put an example down here. It's probably easier to see. So if you see 5C2, or you're taking, this is how many combinations of 2 things can you select from 5? You always put the 5 in your numerator, 5 factorial, like we did the other day. And on the bottom, you do the 2 factorial, which you also do 5 minus 2 factorial, which is 3. One thing about these 2 numbers in here will always add up to be your numerator, always, okay, because you're subtracting one of them from the numerator to get the other one. So when I work these out, I'm going to take the bigger one on the bottom and keep that as a factorial. The top, I'm going to go down to 5 times 4 times 3. Then you can cancel the 3's, work out what you have left. You get 10. But the main point of the slide is how we're setting that up right there. Make sure you're good how to set that up. I'm going to show you 2 examples here. Okay, the first one, a standard deck of cards. 52 playing cards has 4 suits with 13 cards in each suit. And I'll put a picture of a deck of cards here just for those people who aren't real familiar with them. But 4 suits, 13 cards each, and there they are to the side. Part A says, if the order in which the cards are dealt is not important, so you're going to get a hand of cards. Think about it. If you're dealt a hand of cards, it doesn't matter which order you get the cards in, you still have the same hand. How many different 5 card hands are possible? That would be this. That'd be 52C5. All right, so you'd have to work this out. You'd have to say, okay, that's going to be 52 factorial over 47 factorial times 5 factorial. So when you start to work that out, I'm going to go 52, 51, 50, 49, 48, and then 47 factorial. And then on the bottom, I'm going to take the smaller number 5, 4, 3, 2, 1, and also the 47 factorials would cancel. So that was what I punched in my calculator, is what's left there. When I punch all that in, I would get this. Look at this. This is unbelievable. 2, 5, 9, 8, 9, 60. All right, so if you're much of a poker player, that's how many different poker hands there are. You know, so think about being dealt like the perfect poker hand. You know, basically a 4 out of 2.6 million chance. But you're going to get that. So not very good. All right, now let's go to part B. Let me erase this one. All right, part B says, in how many 5 card hands are all 5 cards of the same color? Okay, so that means if they're going to be the same color, there are, you need to choose one of 2 colors and then 5 of the 26 cards in that color. So, because there are only 2 different colors, there's black ones and red ones, and there's 26 red and 26 black. So what I would do in this case is I would say, okay, I'm going to say these are all the combinations of 2 colors. You're going to pick one of the 2 colors. So that's all different ways you can do that. Then once you get the color, there are 26 of the same color, and you want 5 of the 26. So this represents all the combinations of 5 cards from the same color, and this represents all the ways that you can get the 2 colors. So as you work that out, the first one is just going to be 2 factorial over 1, 1. Guys, that's just 2, by the way. Times, then on this one's going to be 26 times 25 times 24 times 23 times 22 times 21 factorial, because on the bottom I would have 5, 4, 3, 2, 1, and then 21 factorial also. Those would cancel. If you punch all that in your calculator, you get this many 131,560. I punched it in earlier, so we don't have to wait so long on the video, but there it is. So I hope that made some sense. The first part a little bit easier than the second, but sometimes you have to multiply combinations together, and that's why they want you to see that problem right there. One more. All right, William Shakespeare wrote 38 plays that can be divided into 3 genres. Of the 38 plays, 18 are comedies, 10 are histories, and 10 are tragedies. How many different sets of exactly 2 comedies and 1 tragedy can you read? Okay, I want you to drill something in your head right now. When you're doing probability, permutations, combinations, that kind of thing, and you see the word and, I want the word multiply to come in your head. You're always going to multiply, multiply, multiply. So exactly two comedies and 1 tragedy would be this right here. There are 18 comedies, so we want all the combinations of 2 out of the 18 comedies, and, that means multiply, 1 tragedy out of the 10. And this is to save time. You know how to set these up. It would look like this: 18 factorial over 2 factorial, 16 factorial, times 10 factorial, 9, 1. And that's just going to equal 10, by the way. Punch it all in, you would get 1530. So there's that many different ways you can pick exactly 2 comedies and 1 tragedy. But the main thing I want you to get from that is the word and. Whenever the word and is involved, think multiply, think multiply. Okay, part B. Part B says how many different ways, different says of at most 3 plays can you read. Now, at most means 3 or more. Sorry, 3 or less. So that means 0 plays, 1 play, 2 play, or 3 plays. So there's 38 plays altogether. So I'm going to do this one. I'm going to say, okay, this is all the ways you could do 3 plays. Or means add. Or this is how many ways you could do 2 plays. Or this is how many ways you could do 1 play. Or this is how many ways you could do 0 plays. All right, so I want to say this right here. Whenever you have a 0, anything C0, it's always going to equal 1. So that's going to be 1. If you have 38, if you have a C1, it's always going to be whatever the first number is. That's going to be 38. So really the only 2 you have to work out are these 2. And I've already done that beforehand just to save some time. That's going to be 703. This first one's going to be 8436. So you just add all those together, you get 9178. But again, the main goal of this slide, I want to train your brain. When you see the word and with probability or combinations or permutations, you're thinking multiply. When you see the word or, you are thinking add all the time, all the combinations. So everything in your homework today is going to be a C. And tomorrow, we're going to spend 2 days doing this. This one video is all you'll have for the 2 days, so refer back to it as much as you need to. And that's really all I got. So have a great day.